Hello everyone, welcome back to my YouTube channel. So as part of this series, we are covering important system design terms that everyone must know. So as part of first video, we have covered these topics: client server architecture, IP addresses, domain name systems, then HTTP, HTTPS, REST, APIs, proxy, reverse proxy, and API gateway. Okay. So now as part of this video, we are going to cover these 6 topics: caching, queues, message brokers, rate limiting, throttling, latency, and load balancer. And in our upcoming videos we are going to discuss these things. Okay, so now without any delay, let's get started. This we have already covered as part of our first video. I will add that video in the description. Now from here we have to cover, right, part 2, data handling and communication. So first we are going to cover what is this caching. Okay, so let's get started. Caching is a process of storing frequently accessed data in a temporary storage cache to reduce latency and load on the server. Okay, and the example for this: so millions of users search for a products like iPhone 14 every minute, right? If every search query directly hit the database, then it would overload the system and it is going to slow down the response time, right? So what is the solution for this? So solution for this is nothing but caching. All right, so let's see the example. User A searches for iPhone 14. Okay, since this is a new query, the app fetches product details from the main database. All right, the result is then stored in the cache with the key like something like this: search iPhone 14 and a time to live TTL of 10 minutes. All right, now same time, okay, maybe next after 2-3 minutes or after 2-3 seconds, okay, there is one user B, okay, and user B searches for iPhone 14, same thing, just let's suppose 2 seconds later, right? The application checks the cache first instead of checking the main database. Okay, the application is going to check the cache first. This time it finds the data already stored, okay, and returns the result instantly without querying the database again. Okay, from cache only we are going to get the response, right? And here we have set this time to live limit of 10 minutes. Okay, so now after 10 minutes this TTL is going to expire, right? The next user's request will again hit the database. Okay, a cache miss is going to happen, right? And here cache hit, when data is there in the cache, then cache hit. If data is not there in cache, then cache miss. Okay, and the cache will be refreshed. Okay, again we are going to set the limit, something like that. Okay, whatever the limit set in code, okay, let 10 minutes, 20 minutes, okay, whatever is there, so we are going to use that. All right, so now common technologies used for caching. So one is this Redis. Okay, so this is nothing but in-memory key value store. It supports TTL. Then this is also famous one, Memcached, high performance distributed memory caching system. Okay, and CDNs like content delivery networks, Cloudflare. So it's going to store this static images, JS and CSS at the nearby servers. Okay, cache static assets at edge servers. Then browser cache, client server caching for the fast page load. Okay, all right, so first let's see the benefits of caching here. Okay, so faster response time, milliseconds versus seconds. Then it going to reduce the database load. Okay, since we are fetching the data from cache only if it is available there, right? Then cost saving on compute and DB resources, and better user experience. Okay, since we are getting the faster results, right? Now let's see the challenges with this caching. Okay, so stale data. So data in the cache may become outdated. Okay, then it's bad now that you are getting the old data. Whenever you are sending the request, you are getting the old data every time. Okay, then it is bad. Okay, so this is the problem with this caching. Cache invalidation, deciding when and how to remove or update the cache. Then memory limits, cache store limited data, it needs proper eviction strategy, LRU, least recently used. Okay, so now first let's understand what is this TTL term. Okay, time to live. Okay, time to live, right? So TTL stands for time to live. It is the amount of time data remains valid in the cache before it expires and is removed or refreshed. All right, so why this TTL is important? So it prevents stale data from being served to users. Okay, right? Then it reduces the memory uses by automatically evicting the old data. It ensures cache consistency with the underlying data source. Okay, done. All right. And many times you see there is issue whenever you are trying to access any website again and again, you get the same response. Okay, and that is not the expected. So many times you delete the cache data, right, from your browser. So this is a first solution, right? Delete all the cache from your browser and then try to reload the same website. Okay, so that's why we do that. Okay, because sometimes in cache we may store the stale data. Okay, now let's move to this part. What are queues? Message brokers. Okay, so a queue is a data structure used to store messages in first out order. Okay, first in first out, right? A message broker is a software that enables different services to communicate with each other by sending and receiving messages asynchronously via queues. It helps decouple components of an application, allowing them to work independently and at different speeds. Okay, so these are nothing but my message brokers. Okay, so let's see the example. So imagine you are at a pizza shop. Customer places order at the counter. Orders are added to the queue. Chefs pick orders one by one and start making pizzas. Okay, this ensures that orders are processed in order and no customer is forgotten, right? So we are taking the orders right in a queue, and from here chef is going to pick one by one. Okay, so here we are adding the orders, like customer A ordered A type pizza, customer B ordered B type pizza, customer C ordered C type pizza. Okay, then chef is going to take A type pizza order. Okay, she is going to prepare that. Then B type pizza he's going to prepare. Then C type pizza he's going to prepare. D type pizza he's going to prepare. Right. So everything is in order, right? So this ensures that orders are processed in order and no customer is forgotten. Okay, so this is the use of this message broker. Okay, so it is a software that enables different services to communicate with each other by sending and receiving messages asynchronously via queues, right? So here, see this scenario. A web application allows users to place food orders, right? The order service API must communicate with inventory service, payment service, notification service. Okay, so without queue, what will happen? All services must respond in real time. If one service is slowed down, the entire system breaks or becomes slow. Okay, so with the message broker, like example of these message brokers like RabbitMQ, Kafka. So user places an order, the order is added to queue. Services like inventory, payment, and notification consume the message asynchronously, right? Even if one service is slow, others are unaffected. Okay, right? This improves scalability, resilience, and reliability, right? So popular message brokers are like RabbitMQ, Apache Kafka, right? So lightweight sports routing, retrieves, and acknowledgements. Then this is high throughput distributed system for real-time data streaming. Okay, so now here let's understand what is this asynchronous mean. Okay, so async means not happening at the same time. Okay, in programming a system, it refers to the task that's run independently and don't block or wait for each other to finish, right? So simple analogy, you can say, imagine you are at a restaurant, you place your food order. Instead of waiting at the counter, you go sit or scroll your phone, right? So you are doing some other task now. You already placed your order, right? The chef prepares your meal in the kitchen. When it's ready, the waiter brings it to you. Okay, so that's asynchronous. Placing an order doesn't stop you from doing other things while it is being processed. Okay, so that simply means asynchronous. Okay, and here let's say a user uploads a file. So with synchronous logic, the user must wait until the file is uploaded, scanned, and saved before doing anything else. But with asynchronous logic, the file is uploaded, a message sent to the queue to scan and process it. The user is immediately shown a success message. Processing continues in the background. Okay, so this is what happens when you upload a video on YouTube. Okay, so whenever you are going to upload the video, so it shows that 100% loaded. Okay, and you can close the window, right? But in the background, processing is happening, or video processing and checking. So everything's happening behind the scene, right? So this is nothing but your definition of asynchronous. Okay, so what are the benefits of asynchronous processing? You can say faster response times for users, handles background tasks smoothly, improves scalability and performance, then doesn't block the system while watching. Okay, so now here we see these three terms, okay, scalability, resilience and reliability. So let's understand them as well, right? Little bit small definitions. Okay, so scalability is nothing but the ability of system to handle more load, users, data requests by adding more resources like servers or memory. Okay, so like can it grow when traffic increases? Okay, so that's the meaning of scalability, the ability of a system to handle more load by adding more resources, right? And there are two types like horizontal scalability, vertical scalability. Okay, we'll see them in upcoming videos. Okay, and then this resilience, the ability of a system to recover from failures and keep working even if parts of it break. So can it bounce back after something goes wrong? Okay, so this is the meaning of resilience. Then reliability, the ability of system to consistently perform as expected over time without errors or interruptions. Okay, can I trust it to work all the time? So that's the meaning of reliability. Okay, so now let's see the next topic, rate limiting. Okay, so rate limiting is a technique which is used to control the number of requests a user or system can make to an API or server within a specific time frame. It protects system from abuse or scam, server overload, bots or brute force attacks. Okay, so here real life analogy, imagine you are entering a parking garage, only 100 cars are allowed per hour. If the limit is reached, the rest have to wait or to be blocked. That's rate limiting. Okay, so rate limiting is a technique used to control the number of requests a user or system can make to an API. Okay, within a specific time frame. All right, so here text scenario, like you ran a public weather API, you apply a rate limit like max 60 requests per minute per user. Okay, so if a user sends the 61st request in a minute, the system responds with http 429 too many requests. Okay, so this is the error that will show up. Okay, so what are the tools and libraries? So API gateways, AWS API gateway, Kong, then nginx. Okay, backend, Redis based counters, middlewares, express rate limit for Node.js. Okay, so why use rate limiting? It prevents DDoS attacks, protect sensitive endpoints, ensure fair use of APIs, and control usage of on paid tiers. Okay, so now throttling. So this is similar to this rate limiting. Okay, how? Let's see. Throttling is a practice of intentionally slowing down the rate of requests or operations to prevent system overload and ensure stability. Okay, so here we are just slowing down the rate of requests. Okay, slowing down the rate of requests, right, to prevent system overload. So think of it as a controlled rate limiting. Okay, instead of blocking excess requests, it delays or spaces them out. So difference from rate limiting here, rate limiting blocks request beyond a defined limit. It slows down or queues requests. Okay, that's simple meaning of throttling. Okay, so example, Netflix might throttle video quality if your connection is unstable rather than stopping the stream altogether. Okay, so API gateways, custom middleware, CDN configurations. Okay, so this is nothing but my throttling. Okay, throttling process. Now let's see the latency. So latency is the time delay between a user's action and the system's response. Okay, so it is usually measured in milliseconds and reflects how fast something happens after a request is made. Okay, so real life analogy, you can say you are watching a YouTube video. You click play. If the video starts in 2 seconds, that's a 2 seconds of latency. Lower latency means faster response. Higher latency means slower or laggy experience. Okay, so what are the types of latency? So network latency, time it takes data to travel between systems. Application latency means time taken by your code or server to process the request. Database latency, time taken to query and return results from a database. Okay, so what are the tools to measure latency? Ping, APM tools, browser dev tools, right? Okay, and why latency matters? Faster apps, better user experience, low latency, higher conversions in e-commerce, in games, critical for real-time actions, right? So here see this ClickWise example. You are watching a live cricket match on television, and at the same time you are checking the ClickWise app for live scores. A player hit a six, you see it live on TV at let's say 12 a.m. Okay, the ClickWise updates the score on your phone at 12:00:03. Okay, just after 3 seconds. So latency is going to be 3 seconds. That 3-second delay is the latency time taken for event to be captured, processed by request servers, sent over the network, displayed on your phone. Okay, so platforms like request, they try to minimize the latency so the score updates feel real time. Okay, ideally within milliseconds or 1 2 seconds. Okay, so real time is our goal, ultimate goal, right? So that is why we need minimize latency. Okay, so now see this last topic, load balancer, right? So a load balancer is a system or a software that distributes incoming traffic requests across multiple servers to ensure optimal resource use, prevent any single server from being overwhelmed, and maintain high availability, right? So real-time analogy, you can say, imagine you are at a busy restaurant with multiple cash registers. Okay, customer walk up to any available register. Okay, the cashier at each register serves the customers. Okay, the load balancer here is the host restaurant manager who directs the customer to the registers with the shortest lines. Okay, least crowd, so no single register get overwhelmed. Okay, so it's not like cashier A B C. Okay, here there is a line of 100. Okay, so we don't want to send the customers to this one. Okay, then we will send them to this B. Okay, because it's empty, or we can send it to C. Okay, so this is the purpose of this load balancer. Okay, so load balancer is a system or software that distributes incoming traffic requests across multiple servers to ensure optimal resource use. Okay, so here example, you can say, let's say you have a website and traffic increases due to promotion. Okay, you have multiple web servers running the same website. A load balancer sits in front of them. Okay, directing incoming traffic based on rules like round robin. Okay, round robin means each request is forwarded to the next server in the least connections. The request is forwarded to the server with the least active connections. Then IP hashing, traffic from specific IP address is routed to the specific servers. Okay, so this ensures that no single server is overloaded while the others stay idle. Okay, so how it works, incoming requests, a user request comes in, right, accessing a web page, let's say. Then the load balancer, okay, the load balancer checks the availability and the health of the backend servers. Traffic distribution, the request is forwarded to an appropriate server based on the load balancing algorithm. Then server response, the selected server handles the request and sends a response back to the load balancer. Then user response, the load balancer returns the final response to the user. Okay, so now let's see the benefits of the load balancer. Okay, so scalability, it can handle increased traffic by adding more servers. High availability, if one server goes down, traffic is automatically rerouted to the healthy servers, right? Improved performance, by distributing requests, it optimizes resource use and minimizes the latency. All right, and fault tolerance helps in avoiding downtime by redirecting traffic if a server fails. Okay, so a real-time example like Instagram uses load balancers to ensure millions of users can post and scroll simultaneously without slowing down the app. Okay, and what are the different texts used for this? HA proxy, AWS ELB, then NGINX. Okay, so this is all for part 2. So I hope that you guys are clear with all these terms that we discussed today, and if you guys still have any doubts, then please ask them in comment section. And now after this we are going to discuss about part 3 in our upcoming videos. Okay, so we have covered all these topics as part of this, and in the next we are going to cover database indexing, database sharding, replication, blob storage, idempotency, then eventual consistency. Okay, so this is important, this is also very important. Okay, they will definitely ask this question during system design interviews. Okay, this is important, this is also very important. Okay, so these three are very important. Okay, so this we will discuss as part of our next video. Okay, so thank you, bye bye.